Sorry about that, ladies and gents, just a technical glitch. So as I mentioned, if you're in a cold environment, and we've got a cold temperature down here, so if you're in Hobart with a hot chocolate cafe, you're probably going to make a lot of money. If you're up in Cairns, where there's temperatures 30 degrees Celsius to 40 degrees Celsius, not many people are going to be buying hot chocolate, so you're not going to make as much money. And so we've got a negative gradient because as we go left to right, we're going downhill. So just moving along there, back to our hill there, it helps us to know the change. A gradient helps us to know the change between two things. Like here with this hill, we're looking at the change of altitude, which is going up here, as we move across left to right. So as we go left to right, a person on this hill is going up higher, and then they get to the peak, and as they continue moving left to right, then they actually start going down. So we see a change in the rise, which is going up and down, with the run, which is going acrossways. So here you're looking at rise over run, which is another way to think of gradient. So like with midpoint, there are three ways that we can measure this. So we can go old school and draw a graph to measure rise and run. So rise is the change in the y-axis, or altitude for the hill example, and our run is the change in the x, which is our distance across the base of the hill there. We can use maths and algebra using the coordinates of at least 2 points from a line, or we can use GeoGebra. I'll just quickly show you the old school way here. I've got a graph here with 0.00 and 44, and we've joined a line segment there, the red line there, and you can see I've just written on the side there, there's the rise, which is the change in the y-axis, and the run, which is the change in the x-axis there. And remember, we read our gradient from left to right. So the gradient of line segment 0, 0 and 4, 4, gradient is rise over run, or change in y, or we use a triangle or delta, the Greek letter delta, which means change in y over change over x. So we have 4 over 4, so we can see go up 4 spaces in the y-axis for every 4 spaces moving across in the x-axis. So 4 over 4, we divide that and we get a gradient of 1. So that is our old school graph way. The other way is using algebra. So we have to name the points as point 1 and point 2. So before I had my point 0, 0 and point 4, 4, and I'm just going to call the 0, 0 point 1 and the 4, 4 the point 2. So our gradient is rise over run, or change of y, delta y over delta x. So this is our formula here, y2 minus y1, so it's the y coordinate of point 2 minus the y coordinate of point 1, divided by the x coordinate of point 2 and the x coordinate of point 1, which equals 4 minus 0 over 4 minus 0, or 4 over 4, which gives us 1. And the other method, just quickly, is on GeoGebra, which I'll show you here. So I've got my point 0, 0 here and point 4, 4 here. They've called it B, and A here for the 0, 0, and I've popped that over there. What I can do is go into this file here and pan down, and I click on in measure, and I click on this one here called slope, and then I go over to my line